This is the case of anomalous origin of left pulmonary artery from right pulmonary artery. That is pulmonary artery swelling. This case has got raised pulmonary artery pressure. In this image, the PRZ, the peak velocity of PRZ is 4.07 meter per second and gradient is 66 millimeter of mercury. So that gradient indicates mean pulmonary artery pressure. The peak velocity of PRZ indicates mean pulmonary artery pressure, and the minimum velocity of PRZ indicates the pulmonary artery diastolic pressure. And TRZ, in case of you get TRZ and pressure across the TR tricuspid valve indicates pulmonary artery systolic pressure. So by PRZ you calculate pulmonary artery end diastolic pressure and pulmonary artery mean blood pressure. Pulmonary artery mean pressure by PRZ and pulmonary artery and diastolic pressure at minimum velocity. So in this image you see here the arrow indicates the peak velocity, that is pulmonary artery mean pulmonary artery pressure, and the minimum velocity, this is the minimum velocity that indicates pulmonary artery diastolic pressure, diastolic pulmonary artery and diastolic pulmonary artery pressure. So by mean pulmonary artery pressure, normal value is less than 15, more than 25 abnormal value. In this case it is 66 millimeter mercury. So pulmonary artery circulation has got more pressure, significantly raised pulmonary artery pressure, mean pressure, diastolic pressure and systolic pressure all are raised together. Again you see right atrium, right ventricle dilated compared to left atrium, left ventricle. Because of pulmonary pressure, pulmonary circulation has raised pressure, ultimately leading to its changes into right atrium, right ventricle. Right atrium, right ventricle are dilated. You can see this is PRZ, pulmonary registration jet. This jet gives you value of peak PR velocity and minimum PR velocity, pulmonary artery and diastolic pressure. You can see this LV is D-shaped, indicating raised pulmonary artery pressure, indicating raised right ventricular systolic pressure. So whenever you find raised right ventricular systolic pressure because of D-shape of left ventricle, that means raised pulmonary artery pressure, because RVSP and pulmonary artery pressure almost same. RVSP and pulmonary artery systolic pressure almost same if there is no pulmonary valve obstruction. In this case, you see here the pulmonary valve is here, the main pulmonary artery comes here and then divides into right and left. This is the place where the pulmonary artery gives bifurcation into right and left. So coming this much, so this is the possibility of anomalous origin of left pulmonary artery. Here you see the left pulmonary artery from right pulmonary artery, because the whole pulmonary artery has come into right side and then it is giving origin to left pulmonary artery. So we call it left pulmonary artery arising from right pulmonary artery. And this is anomalous because this is coming posterior to bronchus, and then what happens, bronchus is compressed, so pulmonary pathology develops, and that because of that pulmonary pathology, pulmonary artery hypertension has developed in this case. So this case the baby is coming with lots of respiratory problem, because pulmonary artery arising, you can see this is most anterior part, skin, the superior part of the skin is the most anterior part, inferior part of skin, the image is the most inferior part. So pulmonary artery is coming almost very inferiorly, then giving origin of left pulmonary artery. So left pulmonary artery going behind the trachea, or you said left bronchus, because left side of bronchus is compressed, and that causing leading to some respiratory disease, respiratory problem, significant respiratory problem, recurrent respiratory problem, ultimately leading into respiratory failure or pulmonary artery hypertension, failure to thrive. So that is the point. So how you decide whether this is anomalous left pulmonary artery? Because left pulmonary is not coming here. Otherwise, in normal case, you will get branches here, right pulmonary artery and left pulmonary artery. Because you see this main pulmonary artery, then it's moving into right side. Before moving to right side, it gives origin to left pulmonary artery also. But in this case, pulmonary artery is not giving origin. Left pulmonary is not coming from here, but it is coming from here. That is very much posteriorly. That is why we call it anomalous left pulmonary artery from right pulmonary artery, because pulmonary artery, main pulmonary artery already has gone into right side, and then left pulmonary artery is coming from there. So that is why we call it anomalous origin of left pulmonary artery from right pulmonary artery sling, because that is compressing the bronchus. Normally pulmonary bifurcation is in front of bronchus, but in this case it goes behind the bronchus and compressing the bronchus, causing respiratory problem. This is the case of anomalous origin of left pulmonary artery from right pulmonary artery or pulmonary artery sling. You can see this is left main pulmonary artery anteriorly descending, and in the same plane anything that is going, then it would be left circumflex artery. That is left main coronary artery. This is left anterior descending part. Left anterior descending part. You see this is left main and anterior descending part. This is anterior descending part. This is right coronary artery. You see this is right coronary artery. This is right ventricle outlet portion. This pulmonary valve. Then main pulmonary artery. Then again main pulmonary is coming into right side and then giving origin to the left pulmonary artery. That's why left pulmonary artery is going behind the trachea. Bifurcation of trachea, that is bronchus, left bronchus, then compressing it, causing respiratory pathology. Ultimately, recurrent respiratory problem, failure to thrive, or severe pulmonary artery hypertension can develop in this case. Thank you.